Good afternoon, everybody. Um, we are getting to the end of topic 5, and this lesson is really going to put together a bunch of the things that we have looked at, hopefully guiding it to make more sense. Also, this is where we're taking equations further. You are going to use this form of equations for several years. So really wanting to focus on this. Now, linear equations in the form y equals mx plus b. This is a very common form. It's called the Y-intercept form that you're going to, or I'm sorry, slope-intercept, that you're going to find in algebra. Okay. I, I know in my class and in most of our 8th grade classes, we will also work with you on converting things from standard form to slope-intercept because slope-intercept is so useful. So in previous lessons, you have definitely learned that m in this formula, okay, m represents the slope of the line. And b in this formula, we just learned, represents the y-intercept of the line. So if we're given the information of what slope equals and what y-intercept equals, we can write an equation. So if my formula is y equals mx plus b, but I know that m should be 3, I could put in a 3 instead of an m. And I know that y-intercept is 1, okay, and that's b. I could put in 1 instead of b. Now, do pay attention. If the y-intercept is a negative number, this is going to be quote unquote subtraction. You're going to have a negative number here. Okay, so we have an equation. That's it. If you know the slope and the y-intercept, you can write an equation. But what would the graph of that line look like? Well, we know the y-intercept, right? The y-intercept is 1. So I'm just going to put a big dot there. And we know the slope, right? So if y-intercept equals 1 and slope equals 3, that's actually 3 over 1, rise over run, and keep writing that if it helps you do these, okay? So that means for my slope, I'm going to go up 3, 1, 2, 3, and run 1 right there. And for my slope, I'm going to go 1, 2, 3 up and over 1 right there. And 1, 2, 3. And I could do that all day long. I'm not going to because we have better things to do. Then take a straight edge. And again, I'm just using a simple piece of paper. Okay, you can use a ruler and draw your line. Your line needs arrows. Okay. That is graphing something in slope-intercept form. You are following step-by-step instructions. Here's where I start, the y-intercept. It's also the start of a story. And here's the slope. How much is it going up or down and back or forth? Up or down, back or forth. All right, so let's try a few more together. On Savas, it asks us to write an equation in slope-intercept form for each line. So let's start at this very first one, A. On A, we see that it crosses the y-axis right here at 1. So we know for sure that our y-intercept is 1. So I'm just going to write myself a note. Y-intercept equals 1. Then we need to look at the slope. Now, I will tell you, for looking at slope, if you don't have specific points, look for a couple corners at which it touches. So in this particular case, if I go up 1, 2, 1, 2, 3, and over 1, my slope is rise over run. So 3 rise, 1 run. Okay. And here are the notes that I made just based on A. All I did was write down a little bit of notes. Okay. Once I have those key items written down, I can remember my formula, y equals mx plus b. And then I just put in y equals, well, my slope is 3 over 1. That's just a 3. And my y-intercept is 1. Boom. You just wrote an equation from a graph. Oh. Let's give another try. On this one, let's give B a try. I'd like to do one with a negative slope. In fact, you know what? I'm even going to skip B. Let's do C because I want to focus on a couple things to point out here. First of all, on C, it does have a positive slope. A little bit different one, but a positive slope. But we have a negative y-intercept, and I really wanted to focus on that. So, making some notes again. My y-intercept is -1, -2, -3. Y-intercept is -3. Okay. And if I look at where's another spot where it touches well on a corner, right there and right there. So if I follow this line and I rise 1 and go over 2, it touches a corner again. If I rise 1 and run 2, again, it's touching a corner again. So for slope, on my notes, I'm writing rise 1, run 2. And I'm going to show you my notes again, this time for C. Okay. And that's all I did. I wrote down my key items. Y equals, well, if slope is 1 over 2, that's simply the fraction 1/2. So instead of m, I'm going to write, let's write it correctly. Here's your formula. And then instead of slope, I'm going to write 1/2 x. And for y-intercept, I'm going to write negative b or -3 for b. Now, this is currently kind of an ugly looking equation. The better looking equation in this case would be y equals either 1/2 x or x over 2 minus 3. You do not need double operations. You know this is a negative. Write it that simply. All right, let's take a look at another. Just one moment. We're waiting for Savas. Okay. Now, in real life, this might be something that we use. The line models the relationship between a temperature in degrees Celsius and degrees Fahrenheit. What is the y-intercept? What is the slope? Okay. The y-intercept is, well, the numbers say 0, 32. So that means that this dot, even though we can't tell exactly, is at 32. So when they give you the coordinates, please use that information. Also, the slope on this one could be tough to figure out. But you have a coordinate pair. You could use the formula that you know, okay, of y2 minus y1 over x2 minus x1 to find the slope yourself. Now, let's take a look at the solution, because this isn't really the one I want to do all the way with you guys. Okay, y-intercept is 32. And then using these points, we put them in the formula, and we get 9/5. This is the formula for converting between Celsius and Fahrenheit. Okay, that's how they found out that formula, is they tracked temperatures. Well, let's take a look at another one. Now they're giving you the formula because we already figured it out. And they want to have you find the Fahrenheit equivalent for 18 degrees Celsius. So if I had a temperature in here, okay, 18 degrees, somewhere right in here, what is my degrees Fahrenheit? Now, this is an application of what we've been doing. And this is the real life way you're going to use this quite a bit. So let's take a look. We have a formula. It says y equals 9/5 x plus 32. And I'm writing this down and we'll show it to you in just a second. And then it's telling us, okay, that x is 18. Because see where you have your x-axis right here? Those are your degrees Celsius. So x equals 18. Well, how do we figure that out? Yes, sorry, I sounded like an evil genius for just a tiny second. We have to use solving an equation that actually has fractions in it. We have to use skills that we already had, okay? So y equals 9 times 5, or 9/5, 18 over 1, and yes, that's a fraction, plus 32. Okay? No, I'm not getting out a calculator because this is how I keep my brain going. Okay? So now I have y equals 162 over 5 plus 32. Now you know why we've done some practice with equations or with fractions. 5 goes into 162. 3. That'll be 15. 12. That'll be 2. And 2/5 times. So this is 32 and 2/5 plus 32, which equals 64 and 2/5. Okay? So 18 degrees Celsius is 64 and a half, almost 65 degrees. Notice we kept it all in line while we evaluated that expression or that equation. I want you guys to go ahead and work on your try problems, work on your homework, and we will see you again in class.